Good morning, students. So today, let us talk about computers in a network. Okay. In the later part of this class, I will talk about software and its types and all. So let's first talk about computers in a network. Today, computers cooperate with one another by being connected to a network. First point, okay, computers are not standalone machines. You can connect one machine with another so that they cooperate with each other to accomplish a task. So from that point, you can classify computers as independent and cooperative. Independent computers cannot affect or get affected by other systems. I mean, purely saying like they do not share any data with other peer computers. But in case of networked computers who are based on cooperative nature, okay, computers share data to accomplish a task. An application run by multiple users can now be hosted on a single machine instead of being stored on individual machines. Apart from sharing files and programs, a network allows the sharing of scarce hardware resources by all connected computers. So computers can share files, programs when different machines are connected with each other with the help of a network. What are the advantages? The advantages are they can share files. Machines can able to share files and programs. A network allows the sharing of scarce hardware resources by all connected computers. Excuse me. A printer can be used by several users if the printer itself is connected to one of the computers in the network. Okay, if the let us say a printer is connected to a machine, then if the machines are connected with each other, though the printer is connected to one machine, it can still be used by all the remaining connected computers. Okay, because of the sharedness. All networked nodes need a common addressing scheme that would ensure delivery of data to the right node. Okay, first of all, in this slide, have discussed about computers in a network. But what's a computer? Computer is simply a collection of a network. Network is a collection of computers. Okay, different nodes. Network topology. There are a number of ways or topologies of connecting computers, each having its own merits and demerits. The types of network topologies are as follows. I mean, there are the way in which different computers can be connected with each other. For that, we follow different network topologies. The first one is called bus topology. Okay, bus topology. In case of bus topology, it uses single bus means what? It's a cable, it's a wire, it's a single cable. As a bus means through which you can transfer information. It's a wire, it's a cable through which all the connected computer, there's a single cable to which you can connect all the machines. So all the machines, they will going to communicate with each other by sending and receiving the messages, by sending the information through the single cable. That bus, the cable, the cable serves as a bus to which all the computers are connected. Okay. The second one is called star topology. Star topology uses a central hub to which all the nodes are connected. It looks like a star. It's a star-shaped connection. That's why the name of the topology is called by the name star topology. It uses a central hub. Okay, there is a node called by the name central hub to which all the nodes are connected. It looks like a star. Ring topology, the shape, because of it's a shape. Okay, here it's called by the name ring topology. Nodes using the ring topology are connected in a closed loop without using a hub. Data moves from one node to the next, one which examines each packet to determine whether it should be allowed to move further on to the next node or not. Okay, it looks like a ring. Okay, it's very simple to transfer the data or the messages from one node. Node here means a computer. Data moves from one node to the next. In okay, packet means information, data. Here, in case of network, okay, so data is observed, it's transferred in terms of packets. The size of each packet being transferred or received, it depends from the machine or from one network to the other. Okay, so bus topology, star topology, and ring topology. These are the different fashions in which computers can be connected with each other. The next one is called mesh topology. Mesh topology. Okay, mesh. You can able to see the different network topologies in the figures. Look at the bus topology. It's a wire to which all the computers have been connected. In the figure given, figure shows that 6 computers have been connected to the single cable. Okay, because of its shape, since all the computers have been connected to the single cable, the topology is called by the name bus topology. Look at the star topology. There is a hub in the middle to which all the computers have been connected. It's called by the name star topology because of its shape. It's called by the name star topology. Then comes ring topology. Because of its shape, it looks like a ring, okay, a circle. Uh, and the last one is called mesh topology. Nodes in a mesh topology are connected to one another, offering a choice of multiple routes for data to travel. Okay, it's like a complete graph. It's like a complete graph. I mean, you can transfer. You can transfer. Look at the figure. You can from any node. You can directly route. You can directly transfer the message or the data or packets to any other node directly, which is not possible in case of all the remaining ring, star, and bus. In a bus topology, if one node or if one computer wants to transfer the packets to the another node or the nearby or the neighboring node, then first the packets must be communicated to the bus, then through which the packets are going to be traveled or received by the other nodes. The same thing happens in case of star. Star, if one node wants to communicate with another node, then the information must first be transferred to the hub, and from the hub, the information can be transferred to the destination node. In case of ring, again, the information, the packet has to travel through all the intermediate nodes. Only then it can able to reach the destination. But the same will not going to happen in case of mesh topology. In case of mesh topology, look at it's like a complete graph. I mean, you can able to route, you can able to send the packets from any given node to any other node in the network. Okay, nodes in a mesh topology are connected to one another, offering a choice of multiple routes for data to travel. When a node breaks down, the packet simply changes its route. Okay, when a node breaks down, if a node breaks down, the packet simply changes its route. Okay, so if there is a failure of one node, then the route of the packet is going to be changed. These are the different types of topologies: bus topology, star topology, ring topology, and mesh topology. Now, let us talk about the different types of networks. Networks are also classified based on their size. The two most common types are the local area network and the wide area network. LANs are used by small organizations where the area of operation is confined to one building. Okay. Network types: local area network, wide area network, and one more can also be added: MAN, LAN, WAN, and MAN. LAN stands for local area network, WAN stands for wide area network, and MAN stands for metropolitan area network. LANs are used by small organizations where the area of operation is confined to one building. I mean, if you want to connect all the computers, for example, if it is a teaching institution or if it is a single building, okay, then all the computers of that organization or of that big one building can be connected using local area network, LAN. All the machines can be connected using LAN. WAN, wide area network, extend the range used by LANs. The range is more. It can connect a number of cities or establishments in the same city. Okay, within the city, it's called metropolitan area network. That's explained later. You can able to see that word in the same slide below, but that will be explained later. LANs are used for connecting all the machines of an organization. Reach ability is smaller compared to, definitely very smaller compared to WAN. Using wide area network, you can connect a number of cities, nodes in number of cities and establishments in the same city. Technology advances have led to the birth of other types of networks. Apart from LAN and WAN, there are also other types of networks. The first one is called by the name Metropolitan Area Network, MAN. This type is sandwiched. I mean, it's in between LAN and WAN. LAN means you can able to connect all the machines of an organization. Okay, its reachability is smaller compared to WAN. All the machines of different cities or establishment in the same city can be connected using WAN. But metropolitan area network, it is in between LAN and WAN, where you can connect the machines of a city. Okay, and other types of other types are campus area network, personal area network, PAN, and CAN, campus area network. So these are the different types of networks, okay, through which we can able to connect the computers, okay, and able to share the data of different computers. Okay, internet. Let us talk about the internet. What is internet? Also called simply today, it's called by the name net. Okay, it's internet. It's the largest wide area network on the planet. It's a network of networks. Okay, what's a network? Network is a collection of computers, connection of computers, connection of different computers. Okay, and what is an internet? It's a network of networks. Okay, so which is the largest wide area network on the planet. It's a collection of over 50,000 networks. I mean, this is roughly speaking, like this data is, since it's taken from your textbook. Let us say the textbook is written a few years back at least. Now, This number is more than 50,000. Okay, internet is a collection of over 50,000 networks that run a special set of network protocols called by the name TCP/IP. The hardware technology used by the internet is no different from any LAN or WAN. Okay, for this reason, it is possible to create small networks of this type that can replicate its services. Okay, this network that runs the same set of network protocols is called an internet. Okay, TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. Hope you have heard of these names at least. They are the protocols. Protocol means a set of rules. Okay, based on these protocols, you can set up different networks, and data can be transmitted. Okay, using the network hardware. I mean, the infrastructure. I was talking about connection of different computers, how the packets will going to be transmitted over the network. But to transfer data, okay, or if different computers wants to communicate with each other, then there must be some infrastructure like hardware, both hardware and software. Now let's talk about hardware. Connecting computers in the network require additional devices that are not part of the computer's basic configuration. In the following paragraphs, okay, I'll talk about the essential devices and components of a network. Okay, uh, network hardware, the hardware required for setting the for the setup of the network is given below. The first one is called network interface card. Network transmission begins from the network transmission begins from the network interface card or network card that is housed inside the computer. NIC stands for network interface card that is housed, I mean, that is situated inside the computer. The card functionality is implemented in the following ways. Okay, built into the motherboards of laptops and current desktops. It is normally built within, it's part of the motherboard that includes all the other circuitry of the machine. Okay, or as a separate card inserted into a slot on the motherboard. Okay, it's either built into the motherboards of laptops and current desktops or as a separate card. It can also be inserted into a separate slot on the motherboard. A dedicated slot, I mean portion, area is available into which it can be inserted. Network interface card is an important one that is housed inside the computer that is required for the connection, and it's an essential part of the computer network hardware. Second one is it's called hub and switch. Look at the figures given below. A accepts hub accepts network data from a computer and simply broadcasts the data to all the nodes. Okay, a hub accepts network data from a computer and simply broadcasts the data to the remaining nodes. Okay, it just passes the data to all the remaining nodes in the configuration. Since the data contain the MAC address of the destination, the data contain the MAC address of the destination, only the node having that address will accept the data. Whichever node is having the MAC address, only that will accept the data. A switch, on the other hand, is intelligent because it has a table of all MAC addresses of the connected devices The switch extracts the MAC address from the data and then looks up the table to determine the node the packet is meant for. This is what is the difference between a switch and a hub. A hub has the MAC address of all the connected devices. Okay, it extracts the MAC address information from the table and determine the packet to be routed towards that node which is having the destination MAC address. Bridge and router. As electrical signals travel along a cable, they weaken. Okay, we know electrical signals whenever they pass through a cable, they will, they will, they will going to become weak. So Ethernet sets a limit on the maximum size of the cable, 100 meters. 100 meter is the maximum size set by Ethernet. A network supporting many nodes must therefore be split into a number of segments with a bridge connecting them. Amplification. It does amplification. It strengthens the signal. Okay. The cable, the node is split into a number of segments with a bridge connecting them. Different segments are going to be connected with each other with the help of a bridge. A bridge maintains a table of MAC addresses of all the machines in the segments connected to it. Okay, a bridge maintains a table of MAC addresses of all the machines in the segments connected to it. A router connects two similar or dissimilar networks uh, which may be separated by long distances. Look at bridge is connected between the segments. The segments, it connects different segments. It strengthens the signal. A router connects similar or dissimilar networks which may be separated by long distances. Let us say two different networks are situated at faraway places. A router connects them with each other. It's a part of both the networks and thus has two addresses. It has two addresses. One belongs to one network, the other belongs to the other network. Okay, so till now have discussed uh, computers computers in a network. What's the network? Okay, network topology, how different nodes of the mesh, how the different computers can be connected with each other. That part constitutes the network topology. There are different types of topologies called by the name bus topology. Okay, it's a star topology. It's not start, it's a star topology. The spelling mistake over there. Star topology. Star topology uses a central hub, as we have seen. Then comes ring topology. Because of its shape, it's called by the name ring topology. You can look at the figures given. Okay, the different topologies given in the figure: bus, star, ring, and mesh. Okay, different types of networks: local area networks, wide area networks, metropolitan area networks. Okay, metropolitan area networks stands in between local area network and wide area network. Apart from LAN and WAN, other networks can also be available, like MAN, metropolitan area network, campus area network, and personal area network. And internet is a network of networks. Different protocols can be used, like TCP/IP is one set of protocols. Okay, other protocols can also be used, like file transfer protocol for transferring the files. Other protocols are also available. You'll learn these things whenever you learn about networks in the upcoming uh, subjects of your higher semester. Network hardware. Okay, the infrastructure required for setting up the network. Okay, constitute the network interface card, which is housed inside the computer, hub and switch, then bridge and router. Okay, these are the concepts what I have discussed as part of network. Okay, and internet. Now let us talk about software basics and software types. Okay, now let us talk about software basics. In the previous classes, we have used these words: software basics. Software is a collection of code. Software is a collection of set of programs. What's a program? Set of instructions. Okay. Software is a collection of code that drives a computer to perform a related group of tasks. Okay. Software is a collection of code. Okay. So as computer subject students, okay, you need to write code to perform a specific task. It comprises one or more programs supported by libraries and configuration files that programs need to access. Software may reside in ROM, RAM, secondary storage, I mean the hard disk, or may be loaded from a network. Look at the words. We have discussed all these terminologies in the previous classes. Okay, software may reside in ROM. What is ROM? What we have discussed about ROM? Okay, it's read-only memory. It's read-only memory. Okay, different types of ROMs we have seen, like programmable read-only memory, erasable programmable read-only memory, electrically erasable programmable read-only memory. Okay, these types we have seen. Random access memory has got as of two types, SRAM and DRAM. RAM is situated, I mean, it is in between the cache memory and secondary storage. First of all, registers are also memory spaces. Registers are part of central processing unit. Okay. Since the number of registers available are few, the next closest repository or memory is cache memory. Then comes main memory. The biggest repository which is closest to the processor is random access memory. Okay. Then comes secondary storage. Important secondary storage device what you have studied is called by the name hard disk. Okay, so software may reside in ROM, RAM, and secondary storage. RAM is volatile. I mean, whenever you switch off your computer system, the content stored inside RAM will going to be erased. So it cannot be used as a permanent storage. Permanent storage is secondary storage, wherein you can store all your data and instructions. So software may reside in any of these type of memories, or it can also be resided. It can also reside in a network. Okay. Today you can also load. You can store your programs, other instructions and data into the drive, I mean Google Drive, or it can also reside in the cloud or whatever. These some of these terms may be new to you, but as you go on learning computer science concepts, you'll learn about these things. Okay. Once these things become familiar, then you can able to understand the concepts very easily. Programs in software use a language. Okay. There are a number of standard programming languages. Even these things we have discussed. Okay. So unlike first and second generation computer systems, where first generation computers used machine language, the second generation computers used assembly language, then there are high level programming languages started with C, C++, Java, Python, okay, Smalltalk, etc. To name a few, basic, etc. So C is an important programming language. In your syllabus, C programming language, uh, you have to learn C programming language. So the name itself is C for problem solving. Look at the title, C for problem solving. You can definitely solve any difficult problem in the world using C programming language. Okay, so C++, Java, they're all object-oriented programming languages. Oh, that is another classification. But in this slide, we have learned what is a software, and what is the importance of software, and where the software will reside. Okay, etc. So next, let us talk about different types of softwares. Computer software can be broadly divided into two different types. Okay, system software and application software. System software, okay, this is the software run by the computer to manage the hardware connected to it. Users don't have much control over its functioning, but their own programs. Application software use the services offered by the system software whenever required. Users don't have much control over the functioning, but their own programs, like users programs are called application software, use the services offered by the system software whenever required. I mean, different system software programs are like a compiler, operating system, okay, database, different system software packages. Especially operating system, it's the biggest system software which resides on the machine. Without the operating system, you cannot able to interact with the computer hardware. In our previous classes, we have also discussed about this word. Okay, the operating system can be anything. When we were students, we were also using DOS, Microsoft Disk Operating System. Today, Windows, probably you have seen and you have used it for your purpose in your home or in your colleges. Okay, Linux, okay, etc. Mac OS operating systems. It's a manager of resources. It's the biggest system software that sits in between the user of the computer and the computer hardware. Since the users cannot directly able to interact with the computer hardware, okay, if any assistance is required from the computer hardware, the assistance, you need to get the uh, help from the hardware only with the help of operating system that sits in between the user of the machine and the computer hardware. It's a manager of resources. Okay, because computers use different types of resources. Users require many different types of resources. Like users require, first of all, users require CPU time, memory, okay, a set of open files, printer, scanner, okay, or any other device or software. Okay, these are all the resources. From the computer point of view, central processing unit, first priority as far as the resources are concerned, first priority is always given to the central processing unit, because ultimately that is the boss which does all the calculations. Okay, so second priority is given to memory, because if you want to execute your program, programs must be loaded into memory before they are considered for execution by the processor. So first priority is always given to the CPU. Second priority, as far as the resources are concerned, second priority can be given to memory. Third priority can be given to all the remaining input output devices. Okay, so system software, as far as system softwares are concerned, uh, users do not have control over the functioning of the system software, but user programs have to get the services offered by the system software for their purpose. The second set of the second type of software, it's called application software. Application software, software not directly connected with hardware, okay, but related to a specific real life situation, is known as application software. Okay, users will write different application programs for clients. Application software are not hardware dependent, so programmers don't need to know the details of the machine that will run the software. So users can run different types of programs use with the help of system software. Different application softwares can be applications for different for serving the different needs. Programs can also be written. Such a software is called by the name application software, and that's all about related to software types. So in case of software basics and software types, we have learned what is a software, where it resides, what are the programming languages that can be used for the implementation of the software, and the different types of softwares like system software and application software. Okay, so in today's class, overall, I brief about again. I'll brief about the today's classes aspects. Have discussed about a network, which is a collection of nodes. Okay, uh, why computers need to be connected with each other for sharing information, files, programs can be shared with other nodes, different topologies like bus, star, and ring, mesh, network types like LAN, WAN, MAN, campus area network, personal area network, and the internet, which is a wide area network available on the planet. Network hardware for setting up the network. Okay, like a network interface card, NIC, which is housed inside the computer. It can be built into the motherboard of laptops and current desktops, or as a separate card inserted into a slot on the motherboard. You can do either. I've also distinguished between hub and switch, bridge and router, then discussed software basics, different types of softwares. Okay, so that's all for today. With this, I will end my session, probably from the next class. Okay, next class, I will start talking about C programming language, its basics, its structure, how to execute a simple C program, etc. And please make use of uh, this recorded video. If you have any doubts, you can ask me, you can contact me anytime. And along with this, a small notes is also provided. And please try to answer the multiple choice questions. It's given for your benefit. uh, just have some curiosity in answering the questions. Don't look into the answers. Try to answer the questions by yourself. And mm, don't worry about whether the answers are wrong or right. Okay, try to answer. And still, if you have any doubts, you can ask me any time. And thank you for listening to me. Okay, we will end our session. Thank you for your patience. Okay.